Hi, it's Christina.
And Susan.
And we are going to work on some hypothesis testing for population means today.
Okay.
This is section 7.3. And we're going to do an example here from the Unit 4 review. It's number 19. So this problem says, the EPA reports the exhaust emissions for a certain car model has a normal distribution with a mean of 1.45 grams of nitrous oxide per mile. The car manufacturer claims their new process reduces the mean level of exhaust emitted for this car model.
You think they're right?
I don't know.
Sorry.
That's okay. A random sample of 28 cars is taken, and the mean level of exhaust emitted for this sample is 1.21 grams with a standard deviation of 0.4. Use a 0.05 significance level to test the car manufacturer's claim. So the claim is that it reduces the mean level of exhaust from 1.45. So that's what our claim is about, is that the new mean, mu, is less than 1.45.
Okay.
And my claim is that I have reduced it.
Yes.
So that is going to be an alternate hypothesis.
Oh, yes, it is. And the reason
There's no equal sign.
there's no equal sign, so
Right. So that's my alternate hypothesis. So my null hypothesis is going to be the opposite of that mu is greater
it's going to be
than.
the complement of it.
Right.
The complement of it.
I know, I should use that word. I always say opposite.
Mu is greater than, but not just greater than, greater than or equal to
Yes.
1.45.
Yes. And so what we are going, and alpha is 0.05, so we can go ahead and write that down. Okay. And then we have this sample data here, and we're going to use our sample data to calculate the test statistic and find the p-value. But before we do that, let's determine what type of test this is.
Ooh.
I know. We know that since our alternate hypothesis has a less than,
Yes.
this is going to be a left tail test.
Yes, it is.
Okay.
Yes, it is.
And the area in that left tail of our rejection area is alpha, 0.05.
Okay.
So to find my critical value,
Because I can't just draw the line. I want to
Okay.
kind of know where the line goes.
you want to find the critical value
So we're going to
first?
find a critical value so that I can draw the line that will separate the shaded rejection region from the rest of
Okay.
it. Let's find it.
Make your graph all accurate.
You know, because look at that. That's so accurate.
So right there, right beside critical value, write T calculator, because I'm going to go to the student T calculator in StatCrunch to find that critical value. Okay. I know that it's going to be a negative number, but I need to go to this calculator. It's just under Stat Calculators T, and I can put in my degrees of freedom. So since this is for a mean and I don't know the population standard deviation, that's why I'm using the T calculator here.
Yes. Yes.
My degrees of freedom is n minus 1. So what's our n, Susan?
What was our n? Oh, a sample of 28 cars. I'm going to write it down.
Okay, so my degrees of freedom is going to be 27.
Because it's n minus 1.
Mm-hmm.
Okay. So I'm going to write that down.
Okay.
Degrees of freedom is equal to n minus 1, which would be 27 in our case.
Okay. So I'm going to put the area in the left tail is 0.0, that's a negative, 0.05, and negative 1.703.
T is equal to negative 1.703.
Yes.
So when I come over here, that's going to be between negative 1 and negative 2, a little closer to negative 2.
Yeah.
I'm going to mark it right here as my T critical value of negative 1.703.
Excellent. Okay.
Oh,
So,
shade my area.
yeah.
There's
there
my
we go.
rejection region, and it has an area of 0.05.
Good. So now we need to find our test statistic and our p-value so that we can make our decision about the null hypothesis.
Right, because the question is, did our sample, the test statistic for our sample, land in the shaded region or outside of the shaded region?
Right.
Okay.
Yep. So we wrote the formula down for the test statistic, but we're just going to get that using t-stats on StatCrunch, and we're going to get the p-value there as well. If you want to use the formula there, you can take your x-bar, your sample mean minus your mu, divide it by your sample standard deviation divided by the square root of your sample size.
Yes.
And you'll get the same thing that we get on StatCrunch. So I'm just going to close this and open t-stats, one sample, with summary because I don't have a list of data. And my sample mean was...
Well, let's see what that was. 1.21 grams.
Yeah, 1.21. Okay.
I'm going to write that down. X bar equals 1.21 grams. And the standard deviation was 0.4.
Okay, 0.4. And we said our sample size was 28.
Yep.
Good. So I'm going to do a hypothesis test. And what I'm assuming is that mu equals 1.45.
Right. I mean, when we did our null, we said greater than or equal to 1.45, but we're going to have to use a mu in our calculation. If we had done this calculation here for the test statistic, we would have needed to use something. We're going to assume it just flat out equals 1.45, okay?
Yep. And I'll look at the p-value plot also. And so let me check here. Sample mean, sample standard deviation, sample size. I've got my null and my alternate. So I think we're good.
Oh, yeah. You know what? I was talking while you marked that alternate. Good job.
Oh, I marked the alternate as less than.
Good.
Okay. So
what do we have?
We have our test statistic is negative 3.175.
Oh, snap. That's going to be in that shaded area.
I think so. And our p-value is 0.0019.
I'm going to mark this on my graph.
Okay.
I'm going to mark the test statistic first, and it's at negative 3.175.
Yeah.
So here's negative 1, 2, 3. It's down here.
Yeah.
So here is my t-test statistic way down in that tail.
Yep.
And this explains why that p-value is so little.
It does.
Why it's so small is because my p-value, man, 0.0019.
Yeah.
That's this little area right
to the left
here,
of the test statistic.
To the left of the test statistic
Yeah.
in that tail
Yeah.
down there.
So that looks like our sample data is significantly less than 1.45.
Yes.
And so since our null hypothesis was that the mean would be greater than or equal to 1.45, our decision is going to be to reject the null hypothesis.
Definitely.
Mm-hmm. Yeah.
And I think we could do that from two different ways. We just talked about how t-test statistic is in the shaded region.
Right.
There's another way to tell it.
Our p-value is less than 0.05.
Right.
Is that the other way?
The other way is our p-value, 0.0019, is less than our alpha was, 0.05. Basically what we're saying is the little bitty area to the left of the test statistic is definitely smaller than the whole area to the left of the critical value.
Yes. And I can look at my p-value plot here, and I can see how small that area is there. Because this red line is indicating where our test statistic falls.
Okay.
Okay. All right. So our conclusion statement then, since we rejected the null hypothesis, we basically had statistically significant data. And so what I'll say is that there is sufficient evidence.
Oh, because we rejected. We saw something significant.
Right.
So there is sufficient evidence.
Mm-hmm. Move this up just a little bit. Oh, no.
There's sufficient evidence to what? Oh. I'll just slide that up then.
Okay, thank you.
There.
There is sufficient evidence to support the claim.
Oh. Wait, we're supporting the claim because we
Rejected the null.
And the alternate was the same as the...
Yes.
Got
Exactly.
it. Got it. Support the claim.
Yes. Okay, so some important steps here when you do your hypothesis test, even if it doesn't ask you, you need to always write what your claim is. Write what your claim and your null and alternate hypotheses are.
Yes.
Because if you don't know what your claim is, then you can't really write that conclusion statement at the end.
It's difficult because you don't know whether you're going to say support or reject. You just don't know.
Right. And then, identifying your critical value and test statistic. Critical values, plural, if it's a two-tailed test.
Oh, yes.
Right?
Mm-hmm.
Make your decision about the null and write your conclusion statement.
Mm-hmm.
I think we're done.
I think we're done.